The last few sessions we've been working with quadratic equations in the form f of x equals a times the quantity x minus b squared plus c. That is known as vertex form. And we've used transformations to graph those parabolas. And that was pretty easy to do without having to make an xy chart. But what happens when your equation is written in standard form, which is more often seen? Standard form is y equals ax squared plus bx plus c. So we'd like to be able to graph those without making an xy chart. And we're going to figure out how to do that today by completing the square. And it's going to be the same general process we used when we were solving equations, but it is just a little bit different. So we're going to be working on changing from standard form into vertex form by completing the square. This first example is just kind of worked through and the words are off to the side. So we'll follow along with it. The first thing we want to do is add or subtract the constant term to the y side. So we're going to be adding 3 to both sides of this equation. So we get y plus 3 equals x squared plus 4x. Then we're going to find half of b. b is still the coefficient of the x term, so b is 4, so half of b is going to be 2. Just like we did when we were solving equations by completing the square, we still square that value, which is 4, and add to both sides. So we're going to add 4. So we get y plus 3 plus 4, which is y plus 7, equals x squared plus 4x plus 4. Then we're going to factor the side with the x squared and the x term by using perfect squares. And remember that we were using this b over 2 value, and since b was positive, it's going to be x plus b over 2, or 2 squared. So we get x plus 2 squared equals y plus 7. Then we're going to add or subtract that constant term back to the other side, so minus 7, and now we have vertex form. And the transformations are that we would shift left 2 and down 7. And we can graph it without making a xy chart. So since that parabola shifts left 2 and down 7, we already know that it has a vertex at -2, -7. So we would graph it by going left 2, down 7. And then from there, since there's no stretch or compression, we'll go over 1, up 1, over 2, up 4, over 3, up 9, and we would get an accurate graph if I had graph paper. We're just estimating on this one. We'll pretend that went through that point. And there's our parabola. So let's practice going through this process of completing the square. With a couple of examples here. We'll start with y equals x squared plus 8x minus 2. Okay, the first step was we needed to move this constant term over to the y side. So now we have y plus 2 equals x squared plus 8x. And then we were going to find half of b, just like we did before. b is 8, so 8 divided by 2 is 4. We square the 4 and get 16. 16 is the number that we're going to add to both sides. So I have plus 16 in here, plus 16 on this side. Then I'm going to add these together, get y plus 18 equals, and I'm going to factor the right-hand side into x plus b divided by 2, which was 4 squared. And then I'll subtract that 18 from both sides, so I get y equals x plus 4 squared minus 18. Now this parabola is in vertex form, and I can easily see that the transformations would be to shift left 4 and down 18, which moves the vertex from 0, 0, left 4, so negative 4, and down 18, negative 18, and there's no stretch or compression, so to graph that I would go make my vertex at negative 4, negative 18, and then move over 1, up 1, over 2, up 4, over 3, up 9, and then make the mirroring points on the other side. We have another one on this page that we're going to look at. Y equals x squared minus 7x plus 21. So we'll start again by moving that 21 over to the y side. So we get y minus 21 equals x squared minus 7x. I need to find half of b. b is negative 7. So negative 7 divided by 2 is negative 7 halves. And then negative 7 halves squared would be negative 7 squared, which is 49, over 2 squared, which is 4. That's the number that I have to add to both sides, unfortunately. So we have to deal a little bit with fractions. Now, in order to be able to add my negative 21 and my 49 over 4, I am going to have to get a common denominator. So I'm going to have to make negative 21 over 1 into something with fourths. So I'll need to multiply by 4. 1 times 4 is 4. Negative 21 times 4 would be negative 84. So I'm going to combine negative 84 and positive 49 over 4. So that gives me y minus 35 fourths equals, on the right side I have x squared minus 7x plus 49 fourths. Next thing I'm going to do is factor the right side. So I'll keep my y minus 35 fourths here, and that's going to equal, remember it becomes x either plus b over 2 or minus b over 2, depending on the sign of b. So I just go back to my b over 2, and that's what I use to factor, so negative 7 halves. So I'll have x minus 7 halves squared. Last thing I need to do is move that 35 fourths back to the other side. So I get my vertex form, y minus 35 4. Oh, I moved the 35 fourths. Just kidding. Y equals x minus 7 halves squared plus 35 fourths. Now the transformations that I have in this function are a shift to the right 7 halves and up 35 fourths. So when I go to graph this parabola, it's going to have a vertex at, instead of 0, 0, it's shifting right 7 halves. So it will be at 7 halves for the x coordinate and up 35 fourths, so positive 35 fourths for the y coordinate. And there's no stretch or compression, so from that vertex I will move right 1, up 1, right 2, up 4, and right 3, up 9.